Hello everyone, myself Bhargav. I'm studying in Sri Venkateswara College of Engineering in CSC Data Science Department. Today our subject is Analysis and Design of Algorithm, and we are going to know about insertion sort. What is insertion sort? Insertion sort is a simple and intuitive sorting algorithm that works by building a sorted array one element at a time. It is a comparison based algorithm that iterates through the input array, inserting each element into its correct position in the sorted portion of the array. Understanding the concept. Comparing elements. The algorithm compares each element in the unsorted portion of the array to the elements in the sorted portion, finding the correct position to insert it. Shifting elements. As new elements are inserted, the algorithm shifts the existing sorted elements to make room for the new elements in its proper location, building the sorted array. By repeatedly inserting elements into their correct positions, the algorithm gradually builds up a fully sorted array one item at a time. Time complexity analysis. Average case. Insertion sort has a time complexity of 0 to the power of 0 into n to the power of 2 in the average case where n is the size of the input array. Best case. In the best case scenario where the input array is already sorted, insertion sort has a linear time complex of 0 to the power of 0 to n. Worst case. The worst case for insertion sort occurs when the input array is in the reverse sorted order, leading to a time complexity of 0 into n to the power of 2. The time complexity of insertion sort is highly dependent on the initial state of the input array, while it performs well on small or partially sorted arrays. Its quadratic time complexity makes it less efficient for large, unsorted data sets compared to other sorting algorithms like quicksort or medsort. Implementing insertion sort. Initialize array. Being by considering the first element of the input array at the sorted portion. Shift elements. As new elements are inserted, shift the existing sorted elements to make room for the new item. Iterate through array. Transfers the remaining unsorted elements and insert each one into its correct position in the sorted portion. Comparing insertion sort to other sorting algorithms. Speed. Insertion sort is efficient for small or partially sorted arrays, but it has a time complexity of 0 into 10 to the power of 2 for large, unsorted data sets, making it slower than algorithms like quicksort or medsort. Memory usage. Insertion sort is an in-place algorithm requiring only a constant amount of additional memory, unlike medsort, which requires extra space to store temporary arrays. Stability. Insertion sort is a stable sorting algorithm, preserving the relative orders of equal elements, unlike some other sorting methods like quicksort. Simplicity. Insertion sort has a straightforward implementation and is easy to understand, making it a good choice for education purpose or simple sorting tasks. While insertion sort is a simple and efficient for small datasets, it is generally outperformed by more advanced sorting algorithms like quicksort and medsort for larger inputs. The choice of sorting algorithms depends on factors like the size and initial order of the data, memory, consent, and the need for stability. Optimizing insertion sort. Reduce comparisons. Track the positions of the sorted portion to minimize comparisons. Exploit partial sortedness. Recognize when the array is nearly sorted to reduce shifts. Binary search insertion. Use binary search to find the correct insertion point. While insertion sort is simple to implement, there are several optimization techniques to improve its performance, especially for larger or partially sorted datasets. By reducing the number of comparisons, leveraging partial sortedness, and using binary search for insertion, the efficiency of insertion sort can be significantly enhanced. Handling duplicate elements. Stable sorting. Insertion sort is a stable sorting algorithm, meaning it preserves the relative order of duplicate elements in the input array. Efficient comparisons. While encountering duplicate values, insertion sort can stop the search as soon as it finds the correct insertion point, reducing unnecessary comparisons. Optimize shift. By minimizing the number of element shifts required during insertion, insertion sort can efficiently handle arrays with many duplicate values. Insertion sort in practice. Insertion sort finds practical applications in a variety of real-world scenarios, partially when dealing with small, partially sorted datasets. Its simplicity and stability makes it a go-to choice for certain problem domains. One common use case is sorting items in a physical inventory where the array is typically small and frequently updated. Insertion sort's efficient handling of partially sorted data makes it well suited for this task. Advantages and disadvantages. Simplicity. Insertion sort has a straightforward implementation, making it easy to understand and implement it, especially for beginners. Efficiency for small datasets. Insertion sort performs well on small or partially sorted arrays with a best case time complexity of 0 into n. Stability. Insertion sort is a stable sorting algorithm preserving the relative order of equal elements. Limited scalability. Insertion sort quadratic time complexity makes it less efficient for large unsorted data sets compared to algorithms like quicksort or medsort. Conclusion and key takeaways. In summary, insertion sort is a simple and intuitive sorting algorithm that performs well on small or partially sorted datasets. While it has a time complexity of 0 into 10 to the power of 2 in the average case, it can be optimized to handle larger inputs more efficiently. I hope that you find what is insertion sort, what are the uses of insertion sort. Thank you for watching my video. Please do like, share, and subscribe.